All right, let's turn to page 30 in your packet, and we're going to do the notes on the outliers, influential points, and leverage. And you needed to have also picked up another piece of paper, and that has got some additional information that we're going to use, okay? I had forgotten to include this in your packet, and it has the notes to the songs on the back, so you can have the phrases for standard deviation of the slope and standard deviation of the residuals as well. Okay, so make sure you've picked that up. All right, so here what we're going to do is talk about, we are interested in what do these unusual points do to the equation of the line. So that's what we want to understand. There are a couple of vocabulary words for what we call those types of points based on where they are located and what they are doing. So first of all, a value is considered an outlier if it stands away from the other data, and really and truly it is an outlier in that y direction. Okay, I wrote here, I see that I wrote here there really is no numerical calculation for outliers, as there are with one variables, but in a sense I think that you can imagine that if you have your residual plot and then you have got your prediction line, and if you have got a point that ended up being more than what? How many standard deviations out? If you have a point that was more than 2 standard deviations above or below the equation of the line, then that actually does make it considered an outlier. So if it is more than 2 standard deviations of the residuals, okay, remember we just practiced looking at what those standard deviation of the residuals are. Okay, an influential point by definition, and it kind of takes things backwards. It says omitting a point. So taking a point away from the data results in a very different regression model, meaning that the slope has significantly changed. That's more of what we're interested in. Remember the y-intercept it often does not make sense. So we're not particularly interested in the y-intercept, mostly if the slope is significantly different. Unfortunately, there's not a I wonder if that means we're changing it more than 2 standard deviations of the slope. Hadn't really thought about that, but that might be something to consider. All right, and the last thing, and we're going to take a look at these items physically here in just a moment. The last item, one that tends to be the most important one that can have the most effect on the equation of your line, are points that have high leverage. So by definition, the data whose points, whose x are far away from the average of the other points, okay? So in the x direction, that's why I have these little arrows over here. So if it is far out in the x direction, then the point has high leverage, all right? In fact, having high leverage, it's got this potential to really change the equation of the line, and strangely enough, it doesn't always necessarily change the equation of the line. So let's look at some of these things with this little applet of actually moving some of these points. All right, so first thing we've got here is we've just got some regular data. I've got the regression line and then what something will look like if we move a point. All right. So I want to point out to you, I want you to look at this data. Looks like it's got a pretty strong correlation. In fact, you can see up here the correlation is 0.98. So we have a strong positive correlation. I want to show you how interesting it is that when I have this point that's right here towards the center of the data, and I make it an outlier, because that's quite a bit away from the rest of the data. Look at how the equation of that line did not really change. There are 2 colors here, a red and a blue, and they did not change that much. Now, this correlation became weaker. This correlation became weaker because this was far away, and so it wasn't as nicely clustered around the equation of the line. But the interesting thing is that the equation of the line itself really was not affected. So just because you have an outlier in the y direction does not necessarily mean that the equation of the line is going to change that much. Yes, changes the correlation coefficient, R value, but not so much the equation of the line. This is where leverage comes into play. So I'm going to take a point that is far out in the x direction. So I'm moving this point far away from the average x value of the other points. So this point out here has high leverage. So this point has high leverage. It is far out in the x direction, has high leverage. Now, it actually is not exerting influence on the line because it has not changed the equation of the line. So interesting that this point has high leverage, but it is not affecting the equation of the line, so it is not being influential. It is not exerting its influence. Now, if I make any small movement of this up or down, it is now significantly impacting, the equation of the line. Okay, so I've got it going down. You can now see that our slope is changing. In fact, I could even have it do this so that I think it changes the equation of the line altogether. You know, it goes, see how strong of a pull it has on the equation of the line. All right, so this is now has high leverage, and now it is being influential because it is not only far out there, but it is way above or below the equation of the line, and it's affecting the equation of the line. Okay, so now let's talk about what happens with the correlation. So here's this point in here, all nice and tidy in the middle of all the data. The correlation is 0.98. And so I want you to watch what happens as we go further out. I want you to watch what happens to the correlation, the R value, correlation coefficient. I'm going far out. I've got high leverage. As I go far out, my correlation coefficient is now 0.997. So if my point falls in line with the data, the rest of the data, I am only strengthening the distance with which the line is appropriate. Because by my point being all the way out here, I'm saying, hey, you know what? This data is linear. It's not only linear around these other dots, but all the way out to this further value, it is still linear. So my linear correlation has strengthened if this point is in line with the other points. Okay? Now, I hope you can imagine what would happen to the linear correlation if this point is not in line with the other points. Okay? There we go. See, now it's totally plummeting that linear correlation, and that makes it at 0.44 right now. Okay? In fact, look at there. I have now changed it to a negative correlation. So once again, if it's way off, it weakens, the R value is weaker, but if it is in line with the other points, it actually strengthens that linear correlation. All right, so let's kind of take a look at those things on your paper that you got today that I forgot to include in your packet, so I gave this to you. Now, so what I have done is I've put the data over here. This first line is the original data. Okay, so you can see the original data, the equation of the line is 0.88 or 0.89x plus 4.27. Okay, and here's what the original line looks like. So I'm going to be drawing the original lines in blue. And so here is the data, and I put one up here. Okay, remember, so think about what this does. You remember me showing you this earlier? Does this point up here change the change the equation of the line very much. And you can see I added in the red line, and the red line is what takes into account this point up here. So the equation went from y equals 0.89x plus 4.27 to the equation of the line being 0.87x, so not too different, plus 4.56. Okay, this is not very much of a change. Okay, however, let's take a look at the correlation. The correlation was 0.987, and now it is 0.927. So the correlation, so this point made the correlation weaker. Okay, so the correlation got weaker. The equation of the line stayed about the same. All right, moving on. So here's this one. What do you have to say about the qualities of this point here? Does it have high leverage? Yes, it does. This point here has high leverage because it is far out in the x direction. Okay? Which, by the way, I should have mentioned up here, this point does not have high leverage because it's located pretty much in the middle of the x values. Okay, so this point does not have high leverage. All right, so let's see what's happening to our equations based on this stuff. So we can see that our equation of the line for this one is the predicted y is 0.19 or 187x plus 8.53. So I'm pretty sure that that really had an impact on the equation of the line. It really was influential in changing that. All right, furthermore, the R value is now 0.24, so that is weaker as well. So this point has high leverage, it is influential, so it has high leverage, it is influential, and it made the R weaker. It impacted the line. All right, and finally, well, no, we've got two more, but here's this one. This point out here, what quality does that have? It is far out in the x direction, far out, man. So yeah, it's got high leverage. Okay, so let's look at our equation of the line. The predicted y is 0.87x plus 4.36. So did it affect the equation of the line much? No, that is about the same. But what I'm interested in is the correlation. Remember I mentioned if you're far out here and you are in line with the data, you are actually strengthening the linear correlation because you are saying, hey, not only is this a line during the rest of your data, but now look, it's a line all the way out here to another point. So that R value is stronger because of that point out there. Okay, and finally, we've got this one point. This is interesting. We've got it kind of, it's, here's the mean of x. So it is out here on the very edge of the data. And what you can see is it's going, and you can see from this picture here, this is kind of pulling up the back end of the line. So this line is kind of being pulled up, and that slope is being impacted. So the prediction line is 0.55x plus 7.06. So I would say that that slope is quite different from the previous 0.87. So I would say that this is being influential. Okay, not quite as influential as this one here that we had, that third one, but it is having impact. And then of course it being out of whack with the rest of the data is making this information weaker, the correlation, the linear correlation, weaker. Okay, so there's lots of information for us to kind of digest on understanding what outliers and such do to the equation of the line, the correlation of it as well. So let's come on here back to your notes. where we've got this right here. Let's see, and we're going to go ahead and kind of fill in some of this information. Okay, so I want us to, on this stuff here, and you're going to do this on your assignment as well, I want us to draw 2 lines. And I know you've just probably got one pencil or one writing utensil. You can use different colors if you want, or you can do dotted line and solid line. So what I'm going to do is I'm going to use one color, because that might be what you're going to do, and I'm going to say a solid line. So the solid represents the line with the special point. Okay, the solid line is what is with the special point, and I'm going to draw a dotted or a dashed line without that special point. Okay, so let's actually do those things first. So on this first graph, draw a line, and you could use the edge of your calculator, the lid of your calculator, to kind of act as a ruler if you want to make a nice straight line. So here it is with the point. That's my attempt at doing it with the point. Now I'm going to remove the point and see what I think this looks like. So I think the line pretty much stayed the same. Okay, so then let's answer these questions. All right, so first, does this point right here have high leverage? Okay, so does it have high leverage? And the answer is yes. It has high leverage because it is far out in the x direction. Does it have a large residual? Is this thing far off the equation of the line? So it is not large residual. And then the other question is it being influential? Removing this point, remember definition is, removing that point significantly impacts the equation of the line. So do you think that is being influential? And I do not being influential. Okay? Question 2. If that point were removed from the data, would the correlation, that's your R value, become stronger or weaker? Okay? So what is this point doing to the line? It makes the correlation stronger, so removing it makes it weaker. Okay? Number 3, if that point were removed, would the slope of the regression line increase or decrease? Okay, so removing this point, what do you think is going to happen? I think it's going to stay about the same. All right, very good. So hopefully you're envisioning what the points are doing to these lines. All right, next, here is our second picture. So I actually think it's easier to draw the one without the point in there first. Here's the one without the point, all nice and tidy and straight like that. So what do you think this point is doing to this line? So I think that it's going to kind of pull down this front section. Okay, so it's going to kind of pull this thing down. So it's probably, and I don't know how much exactly. Am I going to penalize you for having knowing exactly how much it pulls it down? No. I just can tell that you are indicating that you think that this point is pulling down that equation of the line. Okay? You won't get penalized for how much you pulled it down. No, I just want to know that you know how it influenced it. Okay, so let's answer our question. Question 1. Does this point out here have high leverage? Remember, high leverage is far out in the x direction. Far out, man. And it is. It is far out from the other points. High leverage. Okay, the second question is, does it have a large residual? So, that's this thing. What do you think about that residual? I think it does. I think it's probably, a large residual. Kind of depends on where you drew that line. So this is a little bit more subjective without knowing exactly, but I would say probably is going to be pretty large residual there. Okay, next question is it being influential? Okay, remember influential. Influential. If you remove the point, does it change the equation of the line? So if you take away, so going from my solid line to my dotted line, is there an impact on the equation of the line? Solid to dotted, and that is yes, there is an impact on the equation of the line. So yes, it is influential. Okay, number 2. If that point were removed, so again, solid to dotted, what would the correlation do? Become stronger or weaker? So solid, what kind of correlation with solid? With the point in there is weak. So removing this point, the strength of the correlation gets stronger. So you have to really think of how the question is worded. Removing the outlier point makes the correlation stronger. Okay? If that point were removed, how would the slope change? Okay, so let me think. So with this point, the slope is basically, negative. So I guess removing it makes it steeper. Ew. That's kind of hard to tell because, I don't know, are we going to consider negative ones weaker? I'm going to say that the sign matters. So, yes, it does. So it's going to increase the slope because it's going to go from negative up to positive. So removing the point increases the slope. Okay, very good. And our final one. Let's do this one together. So my dotted line, that's not with that point in there. Okay, look at this point right here. Do you notice that it's fairly close to the middle of the data? Do you remember when we had this going on here? And I took a point that was pretty much in the middle of the data and I moved it. Did it change the equation very much? See, now if I'm a little bit to the left, which it kind of looks like this point is a little bit to the left, see, here's the center maybe of the information. This does look to the left, so I think it's going to bring up the rear of this line a little bit because it's to the left of the center. Let me demonstrate that for you. Here I have data. I'm going to say this point right here is a little bit to the left of the center. I'm going to pull this up. See how it kind of pulls up the butt of the rear end of this line. Now it does not impact it very much. It's not majorly influential because it doesn't have high leverage, okay, but it is bringing it up just a little. All right, so back to this. So does this point have high leverage? Is it far away? Oh wait, let me draw my solid line in there. So my solid line, I think is probably going to be something about like this. Just a teeny bit bringing up that rear of the line. So it's not too different, just a little bit different. Does this have high leverage? Question 1. It is not high leverage because it is not far out there in the x direction. All right. Question. Oh, and then we have more. Does it have a large residual? Yeah, probably. It does have a large residual. Residual. Okay. Is it being influential? Removing that point, so going from solid to dotted, is it significantly impacting the equation of the line? And, again, how much is it change? I think that it's not huge. I wouldn't consider that, say, maybe more than 2 standard deviations of the slope. It's not a huge change. So I really don't think it is being, it's not very influential. It's changing it slightly, but not very much. Not very influential. All right, question 2. Removing this point, Does it strengthen the correlation or weaken the linear correlation? This point itself does what to the correlation? This point being out of whack is making that correlation weaker. We can see from our picture here. The correlation 0.99 something or other, and then if I have this point up here, it's now 0.629. So having this point in there is a weaker correlation. Moving this point to be in line is now a stronger correlation. So removing that point makes the correlation stronger. Okay? And let's talk about removing that point. What does that do to the slope? Well, here is our slope like this with the point in there because I pulled up the back end of this line very so slightly. So removing this point then probably is going to a slight increase in the steepness of our slope. Okay? All right, so that is the same kind of questions that you guys are going to answer on your page 34. So if you'll move over to page 34, this is the same thing that you're going to be doing. So you might consider, I don't have this in the instructions, but you might consider doing this thing where the solid line is with the point in there, and the dotted, dashed, or dotted is without the point in there, and draw both of those lines. And then you answer the same questions like what we just answered. Now, I do want to just do one last thing, and this one is so interesting because it takes something that originally had no correlation, and so I want to show you this on the actual internet applet and show you what happens. All right, so first I want to start with there not being much of a correlation. Okay, so that's this red line. Okay, so let's pretend that maybe this is like your IQ and your shoe size. So do you think your shoe size has much to do with your IQ? You know, once you get past of adults, let's say of adults, you know, so let's not include younger people and so on and so forth. Okay, so pretty much no correlation. All right, not much, in fact, look at the R value, 0.035. Okay, so no correlation. Okay, so no correlation. Now, what if Bozo the Clown, who has huge feet, Bozo the Clown, huge feet, is not actually a bozo, you know, he's a freaking genius, like Einstein level. So what if Bozo the Clown is really far out here? He has high leverage because he is so far out here, and I'm having trouble dragging him out there. He is so far out here in the X direction because he's got huge feet. Now watch this. He is a genius. So his IQ is off the charts. So look at what has happened. It has, in fact, look at this R value. It is now 0.84. So this one person, Bozo the Clown, was so influential that he made it go from no correlation, your shoe size and your IQ, to having a strong positive linear correlation. Insane. Okay? So this guy right here was so influential that he took something with no correlation and made it look like it had a correlation. And you're going to find that happening here. So remember that the no correlation line looks flat across. Okay, that's what we had happening whenever our data was back over here. Okay, so no correlation looks kind of like a flat line, but then Bozo the Clown made it look like there was a strong positive correlation between shoe size and IQ and so on. All right, so I just wanted to show you that one last kind of example. There are some other things to show you, these other computer printouts, but I tell you, I think I'm going to save that until tomorrow when I get back, or actually maybe after your quiz. Well, hold on a second. No, tomorrow when we get back, I'll do that part. So I don't want to add too much. I want to give you some class time to work. So your assignment is to come over here to page 34, which is just like what we had done. But I also want to add to that 30 to go through page 37. This one is a review of what you guys did at the end of last week um, with the residuals and such, just kind of a residual review. And then the next ones, these are multiple choice questions. So see, there's only 2 problems on that page, and then this one is a review of what you did yesterday whenever you were given the correlation and the standard deviations and the mean point and all that. So this page, the problems 9 through 11 on page, whatever that is, 37, is a review of yesterday, okay? So your assignment, pages 34 through 37. I hope I've given you enough class time to get a good start on that. 34 through 37.